Welcome back, students. This is the session 26 of JEE Physics, and the chapter is current electricity. And this is a question which was asked in the JEE mains examination a few years back. So here the question here is, two batteries of EMF 12 volt and 13 volt are connected in parallel across a load resistor of 10 ohms. The internal resistance of 12 volt and 13 volt batteries are 1 ohm and 2 ohm respectively. The voltage across the load lies between. So these are the four options which were given in this question. So we have to find the correct one. So this is a question which is based on the concept of parallel grouping. That is, I will try to explain the concept of parallel grouping with the help of an example, and thereafter we will solve this question. So let us consider this cell. Say it is E1. That is the EMF value of this cell is E1, and the internal resistance is R1. And let us consider there is another cell of EMF value E2 and having an internal resistance of R2. Now let us consider another cell E3, that is a cell having a EMF value of E3 and having an internal resistance of R3. Now these three cells are connected in parallel like this, and so these are the 2 points, say A and B. So this is the positive this terminal, and this is the negative. So as per the concept of the parallel grouping, whenever the batteries or these EMF sources are connected in parallel, which are having the internal resistance also, then in that case the equivalent resistance, that is, let us say that is equal to Req, is given by 1 by R1 plus 1 by R2 and so on plus 1 by Rn, where N denotes the number of cells which are connected in parallel. So in this case there are 3 cells which are connected in parallel. So in this case it will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now this is the one formula. The second formula is that is in the case of parallel grouping of the cells, the equivalent EMF divided by R equivalent, which we have just calculated here. This is equal to E1 divided by R1 plus E2 divided by R2 plus and so on, that is En divided by Rn. That is, if there are n cells which are connected in parallel having the internal resistance as indicated here, then in that case the equivalent EMF will be given by E equivalent divided by R equivalent, which is equal to E1 upon R1 plus E2 upon R2 and so on. That is, if there are n cells, then it will be plus up to En divided by Rn. So these are the 2 important formulas which I will be using in order to solve this problem. So I will be writing these 2 formulas on the top, that is 1 by R equivalent is equal to 1 by R1 and E equivalent divided by R equivalent is equal to E1 upon R1, E2 upon R2, En upon Rn. So these are the 2 important formulas when the cells are connected in parallel, and these cells are having some internal resistance also. That is, this E1 is having an internal resistance of R1. E2 is this cell having a EMF value of E2 is having an internal resistance of R2, and so on. So these are the two important formulas which will be used in this question. So now I will be rubbing this, and now let us try to solve this question with the help of these two concepts. So here two batteries of EMF 12 volt and 13 volt are connected in parallel. So here I will be drawing one figure. That is, this is one battery, let us say of 12 volt. It is having an internal resistance of 1 ohm. So this is the internal resistance of this 12 volt battery, and it is connected in parallel to another battery which is having an internal resistance of 2 ohms, and this is a 13 volt battery. Now this is connected in parallel across a resistor of 10 ohms. So here it is connected in parallel across a resistor of 10 ohms. So like this is a 10 ohm resistor. So we have to now find the voltage across this load, that is the across this 10 ohm resistor. So here, as per these this formula, 1 by R equivalent, this is R equivalent is the equivalent this resistance of this parallel grouping. So this will be equal to 1 by R1. So this will be equal to 1 by 1 plus 1 by R2. So that's equal to 1 by 2. So this is equal to 3 by 2, or we can say that R equivalent is equal to 2 by 3 ohms. So R equivalent is equal to 2 by 3 ohms. Now, equivalent EMF divided by Req, this is equal to E1 upon R1 plus E2 upon R2. So here I will be if this is E1, then 12 upon R1 will be equal to 1 plus, if this is E2, then this is 13 divided by 2. So this is equal to 24 plus 13, that is equal to 24 plus 13, yeah, 37 divided by 2. Or it implies that E equivalent, that is the equivalent EMF of this parallel grouping, is equal to 37 by 2 into RQ. RQ is equal to into 2 by 3. So this is equal to, 2 will cancel out, that is equal to 37 by 3 volts. So R equivalent was the equivalent resistance of this parallel grouping, and E equivalent is the equivalent EMF of this parallel grouping, which is equal to 37 by 3 volts. So now I will be writing these two values here. I will just write this E equivalent. Volt, and now we have to find the voltage across this 10 ohm resistor. So the voltage across this 10 ohm resistor will be equal to E equivalent divided by the total resistance into 10, where 10 is the resistance of this resistor. Now equivalent is equal to, which we have calculated, that was equal to 37 by 3, and the total resistance will be equal to, see, the equivalent resistance of this parallel grouping was equal to 2 by 3. So the total resistance here will be equal to 10 plus 2 by 3 into 10. So now this is the voltage across this 10 ohm resistor. Now, and we have to only simplify this equation. So by solving this equation, we will be getting the value as V is equal to 37 divided by 3, and this will be equal to 30 plus 2, that is 32 by 3 into 10. So this is equal to 37 by 3 into 3 by 32 into 10. So, or we can say that V is equal to 37 divided by 32 into 10. So this will be equal to 37 divided by 32 is equal to 1.156 into 10. So this is equal to, into 10 is 11.56 volts. So the voltage across the load across this 10 ohm resistor is equal to 11.56 volts. And here we have been given 4 options, that is the voltage across the load lies between. So this is 11.56, so this is lying between 11.5 and 11.6 volt. So our correct option is B. The correct option is B. The correct option is B. So in this question, the most important thing which we have to remember was that in the case of parallel grouping, the equivalent resistance is given by 1 by R1 plus 1 by R2 up to 1 by Rn, and equivalent EMF divided by equivalent resistance is equal to E1 by R1 plus E2 by R2 up to En divided by Rn for the this parallel grouping of these EMF sources or the cells. So by using these two formulas, we were able to solve this question, and this question was asked in the JEE mains examination few years back. I don't remember the year in which it was asked, but it was definitely asked in one of the JEE mains examination. So thank you very much for joining this session, and in the next session I will be continuing with the same chapter, that is current electricity. So till then, have a nice day. Bye.